Today's activity is going to involve sketches and calculations for lenses. And remember from the last video that the thin lens equations are the same as for mirrors. 1 over DO plus 1 over DI equals 1 over F. And the magnification is minus DI over DO. Remember when you do the calculations, if you have a converging lens, F is positive. If you have a diverging lens, F is negative because the focal length is on the same side as the object. DI is going to be positive if the image is on the opposite side, and it's going to be negative if it's on the same side as the object. And HI and magnification are going to be positive if the image is upright. They're going to be negative if it's upside down. So we did some quick sketches and some sample calculations with letters for DI and DO in the last lecture. Let's do some calculations with numbers. So I've got an object is 10 centimeters in front of a diverging lens which has a focal length of 5 centimeters. Where is the image? So reading this, we say the object is 10 centimeters. So that means DO is 10 centimeters. In front of a diverging lens with a focal length of 5 centimeters. So focal length, F, is 5 centimeters. But because it's diverging, we're going to use a negative sign. And where is the image? So it's asking what's DI. So what equation are we going to use? Well, we're going to use the equation yellow at the bottom. 1 over DO plus 1 over DI equals 1 over F. We know DO and we know F. So 1 over DI is 1 over F minus 1 over DO. Okay, so that's 1 over negative 5 minus 1 over 10. So you can see if you had put in, if you'd forgot that for diverging you have to make the focal length negative, you'd get a very different number when you did this calculation. So when I do this calculation, I get 1 over negative 5 minus 1 over 10, so that's minus 2 over 10 minus 1 over 10, that's minus 3 over 10. So DI is going to be 1 over negative 3 over 10. So it's going to be 3.33, negative 3.33. Centimeters. Okay, so what does it mean that it's negative? Negative means that it's virtual. And we know for a diverging lens that we should always get a virtual, upright, smaller image. And we can see from the numbers here that that's what we get. What's the magnification? Magnification is minus DI over DO. So it's going to be minus negative 3.33 over 10. So it's going to be plus 0.333. So what does that mean? Well, the positive means it's upside right. And the 0.3 means it's 0.33 times the height of the object. So the magnification is a third. So that's dropped down to a third of the height, so it's smaller. So for diverging lens, we got an upright, smaller image that's virtual, and that's what we expect. Okay, let's do another calculation. So this time we have an object is 27 centimeters to the left of a lens. And they don't tell us what kind of lens it is. So let's just sort of draw a box there. We don't know what's in that box. So we've got our object is 27 centimeters on the left of the lens. So DO is 27 centimeters. Creates an image 15 centimeters on the right side of the lens. So we want to know what's the focal point. Is the lens converging or is it diverging? Well, obviously it can't be diverging, right? Because a diverging lens would create an image on the same side as the object. So it can't be diverging, so it must be converging. So we could even sketch in our lens. There's our lens over there. It's going to be wider at the center than it is at the edges. All right, so what's the focal point? Well, we know DO and we know DI. So we just do 1 over F is 1 over DO plus 1 over DI. So it's 1 over 27 plus 1 over 15. And when I do that, I get 0.1037. So that means that the focal length is going to be 1 over that. Remember, I've got 1 over f is 0.1. So it's going to be 1 over 0.1037, which is going to give us something just a bit less than 10. 9.64. I guess I should round that to two significant figures, 9.6 centimeters. So the focal length of that lens is 9.6 centimeters. If I were to draw my image, how do you think I would draw it? Is it going to be upside right or upside down? Well, whenever you have a real image, if it's a single lens, that real image is going to be upside down. So I'm going to draw my image will be inverted. And will it be larger or smaller? I'm going to say it's smaller. Why is it smaller? Because it's closer to the lens than the object is. But let's just do a calculation. What's the magnification? Magnification is minus di over do. So it's going to be minus 15 over 27. And let's see, what do we have? So see, both of those divide by 3. So it's going to be minus 5 over 9. So it's going to be what? 1 over 9 is 0.111, so it's going to be minus 0.55. Okay, so the negative means it's upside down. The magnification of being 0.55 says that the image is 0.55 times as high as the object. Okay, so what I want you to do is to do the same thing that we did for mirrors. I've got a table here with every possible combination of what you could have. So I've got converging lenses and diverging lenses. I give you various DOs. Assume that the focal length for all the lenses is 10 centimeters. Remember, you got to get the sign right for converging and diverging. Use the 3 special rays that are written down below to draw a sketch for each of the 5 cases, A, B, C, D, E. And then use the equations at the bottom to also calculate DI and M in those last 2 columns and see whether that agrees with what you got from your sketch. Remember, again, you're going to have to draw a picture for mirrors and a picture for lenses on the exam, so make sure you know how to do the drawing and the calculations.